All right, so here the focus is on graphing linear relations, which we've really been doing throughout this chapter so far, but a focus more on graphing equations instead of just graphing a table, although tables come into play. So first I want to start with something that we've seen a few times, a sort of general form of a linear relationship, we call it. And so in this case, if you have an equation in this form, the coefficient of x is your average rate of change. And that could take on many meanings depending on what the context is. And quite often we call this slope. That's really a term, like I said before, that is formally introduced in grade 10, but it's less syllables than average rate of change. And b, the constant term, that's our sort of starting amount or initial amount. Or you can call it the fixed amount. The constant, the amount that we have at the start. And so in general, if you have an equation like this, it's literally telling us a rule about how to determine any y coordinate if you know an x coordinate. It tells you the rule, y equals, the y coordinate equals this, whatever x is times some number plus some number. It's mathematically telling you the rule of how you can find any y coordinate if you know an x coordinate. And if you have that rule, we can then visualize it as a graph or a table. But really, our focus is going to be more and more on the graphing side. And so, for example, I have this equation. 1.5 I can see as my average rate of change. -3, or -3, is my initial amount. So I'm going to, for each of these questions, I'm going to jump to the table and then go to the graph. Eventually, though, our goal is if we can just go straight to the graph. That's our goal. But it's never wrong to make a table. With that said, for my table, I got x and y. I'll just pick some numbers for x, calculate some values for y, and plot these points. Once I see the points, it should form a visual pattern that I can just then show with a line. So I can pick any number 1 for x. I'd always recommend picking 0. And maybe I'll just, in this case, I'll go 0, 1, 2, 3. Although if we always do that, quite often, depending on the values of the equation, our points shoot way off the graph right away. But 0 is a great point to start with. When x is 0, y is -3. 1.5 times 0 is 0. 0 take away 3 is 0 take away 3 is -3. So next, if I put a 1 in there, then I get 1.5. I put 1 into the x. So I get 1.5 times 1 take away 3, which is 1.5 take away 3, which is -1.5. Put in a 2. And the same idea, substitute x with 2, and I get 1.5 times 2 take away 3, which is 3 minus 3, which is 0. Really nice number. And put in a 3, you get 4.5 minus 3, which is 1.5. And so if I plot these points, 0, -3, 1, -1.5, 2 and 0, 3 and 1.5. Notice I'm seeing this straight line forming, which if it didn't, I know I made a mistake, because there we go. There's my line. I'll now connect the dots, show that this relationship, this line, is not just these 4 points. It goes on forever. It's an infinite number of points, because I could have picked any numbers I wanted for x. And there's my equation of y equals 1.5x minus 3. Notice the -3, the constant, the start, is the same as my y-intercept. And so that is not a coincidence. That'll always be the case. And so I'm going to put that up here as well. Not only can that be the initial amount or the fixed amount, I'll say it's the y-intercept. So many connections here. All right. So I can do this with pretty much any, if my equation is a linear equation, and if it's a linear equation, that means it's a polynomial of degree 1, which means there's x to the power of 1 here. If you see x to the power of 2, then it's not linear, which means you can graph it, but it won't form a straight line. And to be honest, you won't see that much, because that's not really the focus of this. And so if you have a linear polynomial that we're graphing, then once you have a few points plotted, you should be able to just connect the dots. But always plot a few until you can see the pattern. All right. I have two kind of special examples here. Here my equation is x equals 4. There's no y. So x equals 4. So what does that mean? Well, as a table, that means x has to be 4. That's what it means. I have to pick 4 for x. I don't have a choice. It literally says x equals 4. So a good question is, well, what's y? Well, there's no y in the equation, which means y can be anything. Y can be 0, 1, 2, negative 1,000. It can be anything. So what does this look like if x equals 4? Again, the equation x equals 4 is a very simple equation, but what does it look like? Well, if I plot these points, I have 4, 0 for 1. 4 on the x, 0 on the y. Then I have 4, 1. I have 4 and 2. And I have 4 of negative 1,000, which is way down. But I can already see it is forming a line. It's forming a vertical line. And this vertical line is the graph of the equation x equals 4. Essentially, the y coordinate doesn't matter. X is always 4. And if you visualize on a two-dimensional graph where x coordinates equal 4, it's along this vertical line. So x equals 4 makes a vertical line, which means you can probably now guess that this is going to make a horizontal line where y equals negative 2. Maybe sounds backwards first, but notice again, in this case, y has to be negative 2. It can't be anything else because the equation says y equals negative 2. X can be anything, 0, 1, 2, 3, whatever. And so it doesn't matter what values I pick for x. It'll form the same graph. Because if y is negative 2, for example, look at this first point, x is 0, y is negative 2, that's right here. Next point, 1 and negative 2, that's right here. And the next point's right here. And you get the idea. I have this horizontal line being drawn at all the places where y is equal to negative 2. And so there's the graph of the equation y equals negative 2. So in general, if you have an equation with just a y or just an x, it's going to be a perfectly vertical or perfectly horizontal line. If you have an equation with both, it's going to be on have some sort of slope, some sort of diagonal. And if your equation is not of degree 1, if you have an equation like this, y equals x squared, which you won't see much at all in this course, but if you do, there's a few examples in the textbook, then that is not a linear relationship. That's a higher degree polynomial, and you can graph it, but if you make a table, you'll see the points maybe make a curve of some sort, which is more complex, and hence it's not really the focus of what we're doing right now.